This is House Planning Help episode 308. Hi there, I'm Ben Adam Smith, and this is the podcast for you if you're interested in self-build or retrofit. I'm exploring what houses we should be building in the 21st century and try to break down the major roadblocks that may get in our way. Coming up in this session, my guest is Tom Fenton from Veritherm, and we're going to be looking at rapid thermal performance testing. One of the great things about running this podcast is some of the opportunities that creep out of the woodwork, and I'm delighted to say that now I'm taking part in a monthly call for Passive House Accelerator, and this is devised by Partel. Hugh Wiriski, he said, "Ben, do you want to join the panel here? We'd really appreciate it if you do." And I love this, just getting more of the word out there, stimulating discussion, learning. And our first call was with Thomas O'Leary from Passive House Academy, who's just a great guy all round, but says some really interesting, thought-provoking, useful things. And he's been around this whole topic for quite some time. And he was showing us all of the training centres and some of the various different elements that they're trying to just upskill as many people as possible. So that's what this Building Performance Interactive is all about. Co-host as well with Mike Jacob, who's been on the podcast before. He's the man behind Kiss House. So the three of us get to chat to some really interesting people, and we think you might like it too, which is why I'm going to put a link in the show notes today. And then that will signpost you as to where to come, or just head to the Passive House Accelerator website. I'm sure you will find it amongst a list of events that are going on, all sorts of things they do there, constantly expanding their repertoire, which I like. Let's get to our featured interview with Tom Fenton from Veritherm. We all know the importance of insulation, yet it's one of those key components. But what if you want to test for insulation? How do you do that? It's particularly relevant, I guess, if you're actually just moving into a property and you want to know, well, how well are we insulated here? So let's have a chat with Tom. I started by asking him to tell me a little bit about himself.
My background started in design, actually. So together with my parents, we ran a bespoke design consultancy that focused on building envelopes, so facades for industrial units and commercial properties, and ultimately specialized in how those facades went together from a construction perspective, but as well as performance and other things. So that experience in design led us to come up with the idea of Veritherm. We sat in quite a unique vantage point, actually, where we could see all of the pitfalls in the design and construction process that would kind of impact the performance of the building fabric, but quite often sat at the bottom of the supply chain, couldn't really do much about it. So yeah, that's my background. Worked from school in the construction industry, started off as an apprentice looking at engineering, both mechanical and electrical engineering. And then once that apprenticeship had concluded, I then joined the family firm.
Thermal performance then, what is a good starting point for this?
I think thermal performance is very little understood actually in our industry. It's something that's quite notional. We use theoretical design assumptions to understand thermal performance, but actually true building performance or true thermal performance in buildings is rarely measured, which means that we don't really have a benchmark to understand where we are, where we're going, or where we need to be, really. So I think that that's where our ethos comes in terms of we're promoting measurement of thermal performance in favor of desktop modeling exercises, which seems to be the status quo at the moment.
Why does it not get measured? It would seem an obvious thing, doesn't it? End of the process, you've built a building. Now let's see how it did. Is it just the test wasn't there, or why?
Yeah, I think until recently, there hasn't really been a commercial facing solution that will allow us to do it. So there's academic approaches, but they tend to be very complex, expensive, very much implemented at a research level, meaning that it's not really suitable for mainstream construction projects. So that's where we come in, really. We're trying to kind of make thermal performance measurement simple, affordable, and ultimately scalable, so people can integrate it into their projects without it costing them an arm and a leg. And yeah, until the last 2 or 3 years, there haven't been many tools to do that.
Affordable is quite an interesting point, isn't it? Because the amount of money you spend on a building actually you're willing to invest quite a lot in knowing that it's doing what it's supposed to. But that's not always the case, is it? So what becomes affordable?
Yeah, it's bizarre, really, because we use this analogy all the time. Your appliances in your home go through more of a robust testing and verification process for performance and energy efficiency than a £200,000 newly constructed home, which seems really bizarre. So yeah, I mean, coming back to that point, the affordability element. So existing research level tests for thermal performance might cost you somewhere in excess of £10,000 per property, which obviously is not a palatable price point in terms of mass rollout. But in terms of our system, you're looking at somewhere around about £500 per home. But obviously, understanding that could give you fantastic data to allow you to make informed decisions, as well as a really good quality control tool. The value far outweighs the investment at this stage. So we're starting to see quite a lot of appetite now that price point is starting to come down.
Now, for me, the obvious one is at the end, but are there other uses of this in buildings that perhaps might need retrofitting, or is that not the primary use of it?
Everybody says the end, but it's probably the least valuable time to test, in my opinion. It's needed, and we do a lot of pre-handover testing, but about 50% of our work is actually in the retrofit market. So we might take a baseline measurement of the existing home to understand how it's performing, then feed that data back to the design team so that they can look at fabric upgrades that are actually suitable for that property. And then we can actually introduce testing throughout the retrofit process. So as you install a new element to the building, so whether that's double glazing, loft top-up, external wall insulation, you can actually quantify as you go to ensure that those benefits are being realized, and then obviously post-completion as well. We're also working with self-builders, certainly in the passive house market, where we will actually do two tests. So one, once the insulation is in, but the external linings aren't installed. So if there's a howling error, you can actually identify it with further diagnostics and possibly remedy those issues with the external envelope before sealing it up.
Do you find, having tested a number of passive houses, that actually there is a variation in the consistency according to the build method?
Yes, I think certain build or archetypes or structures tend to perform better than others. We've tested a lot of buildings with steel and metal in them, and obviously in terms of thermal conductance, it's not as good as something like timber or blockwork or masonry like you suggest. So you can start to see those trends. What I would also say is that we talk about trends, but a lot of it is down to the build quality and the detailing, actually. So you might have a fantastic property with high performing products and specifications, but if you haven't got the detailing quite right between junctions, around windows, etc., it can really be the downfall of the property. Heat's like water; it will find your weakest point, and that's where you're going to be losing energy from. So, we've tested lots of passive house dwellings that are fantastically insulated, bar one really howling error, and ultimately that means that property is substandard in comparison to its design predictions. We also have others that exceed their thermal specifications. So yeah, it's a really interesting one, but ultimately if you can catch it at the right time, you can pinpoint these errors and like I say, rectify them before the building becomes operational.
Can you take us through the actual test and what it entails?
Okay. It generally goes in three phases. So there's a setup phase. So that includes retrieving the thermal specification for the property, entering in some basic dimensional information for the building, and then actually deploying the kit inside the property. So that includes environmental sensors, so mainly recording temperature readings. They're typically deployed one per room in the property so that we can actually label each sensor per room, so that if possibly a room isn't getting warmer or cooler than others, you can start to pinpoint errors in the building. And then we apply a controlled and measured heat load to the property. So we actually deploy space heaters inside the property, and then we circulate air with fans. Once that's done, we then create a heating curve. So we turn on the heaters all remotely via our platform, and we heat the building for 50% of the evening. We then cut off the heating and allow the building to cool passively. And then all of that data, along with the power data, is sent up to our cloud-based software, run through the algorithms, and you can actually then generate a result. So Veritherm encompasses all energy loss from a building in units of watts per Kelvin. So the easiest way that I can explain that is Veritherm quantifies the rate of energy loss in your building per degree of temperature difference. So that can be useful for understanding whether it complies to the design, but it can be fantastic as well to understand actual heat losses for the purposes of sizing or specifying a heat pump, for example. So yeah, it's quite a simple process. It's a 12-hour overnight test, so it's very quick, and results are instantaneous. So once you've gathered the data, through the click of a button, you will retrieve a full report, which will break down those losses into various areas. So we quite often carry out an air leakage test so that you can understand what losses are attributable to air infiltration, so gaps and holes, and what losses are attributable to fabric, so insulation performance. And obviously that gives you a lot of clarity on how your building is performing as built, rather than relying on, say, PHPP calculations or the standard SAP process that is used to generate a building's EPC.
So you talked about PHPP there. I mean, is there the opportunity almost to export that data? You have a lot of data in PHPP, which makes it such a great modeling tool. But then when you get your report, let's say, for example, there's a thermal bridge, how do you identify that specific point of where it's happening?
So Veritherm doesn't identify the specific points. It can identify possibly areas or zones of a building that look questionable. So at that point, you may decide to do some further diagnostics, so whether that's a thermal imaging survey or other things. But the real kind of useful element with Veritherm is we can pull the data from a PHPP calculation or a SAP assessment, for example, but you can actually then push the data back, which will allow you to model in the real world performance and communicate to your clients actually what impact that has long term, whether that's on emissions or fuel bills or heating demand. So you can actually use those figures and start to model scenarios based on what you've got. In terms of diagnostics, it's quite an unusual one, really, because it's the chicken and egg scenario. If you do a thermal imaging survey and you see thermal bridges and different bits and pieces that look questionable, you have no real tangible evidence whether that's significantly impacting the performance of your envelope or not. Ultimately, windows will still show cooler than the external fabric, for example, but actually, what do those images mean with regards to performance? So that's where thermal performance measurement comes in, is it can give you a quantification that can then be used alongside other diagnostic tools.
So these sensors that you've got in the rooms, is there a standard placement for them? Because that could be in some buildings where you place it in the room could be a different temperature, or is that really not the case? It's always going to be a sort of ballpark figure.
It's basically the more data points in the property, the better the outcome, I would say. Typically, it's one per room, but on each sensor, you have a high and low level temperature probe. So you're actually taking two measurements at different heights within a room, which gives you a better overview of the average temperature in that space. To be honest, with the type of measurement that we produce, adding additional sensors in a room probably wouldn't enhance the quality of the result. I think it's actually more about the application of heat and the air mixing inside the property that is the important thing. So that's why we introduce fans inside the property, is so that ultimately we can get uniform temperature rise in the property. So you don't want to have a specific room in the property that isn't getting heat, for example. But in terms of the sensors themselves, normally they're just central to the room.
Can you explain the difference between thermal imaging and the process that you're undertaking?
So thermal imaging is a visual inspection of heat loss in a property. It will give you an image that a person then has to interpret and possibly identify what that means with regards to energy loss in the building. With Veritherm, we take a drastically different approach in that we quantify the rate of heat transfer. So we actually give you a physical number at the end this is what the building was designed to achieve with regards to the rate of energy loss, and this is what it's actually achieving. With that number, then you can then break it down into different things. So how is this property performing thermally on a scale of very good to very poor, for example? What's the average U value across the building envelope? What's the gap in performance between designed and as built? So it's a quantification, it's physical evidence and data and numbers that can be utilized to inform decision making. So you could feed that information back to an architect to help them actually improve the design-led process. You could feed that information back to a self-builder. So, for example, if you've got a 400% gap in performance, it may be that self-builder needs to look considerably at improving the envelope. If there's a 5% gap, then actually that's not going to make a huge difference on their fuel bills and their emissions. So I think it's that tangible data and evidence which can be paired with thermal imaging, but thermal imaging is quite constrained in that if you're not trained very well, the images can actually not show you what you need to see, as well as only being useful at night time. So you've got to go out and actually gather those images at the right time in the right place. So that's how they differ. But what I would say is they complement each other quite well.
Yeah. So is this really about the U value? You're sort of verifying that and coming up with a number?
Yeah, basically, whole building U value that then can be split down into different kind of outputs. But ultimately, yeah, we are verifying that number quickly and efficiently.
Now, when we get the reports, how is that laid out, or how are we going to use that?
So we will break down your energy loss into things like air tightness, fabric, and ventilation. We will also give your building a thermal efficiency rating, a bit like what you see on an EPC certificate. So that kind of traffic light system. We divide the rate of energy loss by the usable floor space inside the property, which allows you to say compare a 5-bedroom dwelling to a 1-bedroom bungalow on the same scale. We also quantify the performance gap as a percentage. So if there's a gap in performance, whether that's a positive or a negative gap, we can actually translate that to the customer, as well as giving an average U value across the building envelope, which can then be used to influence design and decision making. The other thing that we're using it for quite frequently is for the purposes of sizing heat pumps. So we'll actually use those values to influence sizing and balancing of heating systems. So, for example, a new build property might underperform, which means the heat pump won't be able to kind of run efficiently. And quite a lot of existing buildings may be oversized to compensate for the unknown, which means it's a lot more expensive. And again, if you oversize a heat pump for a building, it's not going to run how it needs to. So we've had a few scenarios where we've done that, and there's cost savings, so capital savings on equipment as well as operational savings as well, using those real world values.
So you mentioned positive and negative numbers when it refers to the performance gap. Is it most of the time negative?
Yes, if I'm honest.
I just wondered.
Yeah, I mean, certainly kind of newly constructed homes. So if you've got to imagine that every energy calculation that is done for a home is based on an idealized build. So we take standard U values from data sheets provided by manufacturers, and we assume that value will be achieved in situ without considering all of the other things that goes on, the things like workmanship, replacement of materials, thermal bridging, even design errors. It can go right back to the design, and all of those things added up can deliver a home that's underperforming considerably against its design. However, there are occasions where performance is right at the top of the agenda on a particular project, and we see homes exceeding their thermal specification. Quite a lot of existing homes as well tend to exceed their thermal specification. So say it's a 1920s home where we don't have any U values from product manufacturers and the fabric specification isn't understood. If we're going to retrofit a heat pump or specify fabric upgrades, then quite often we see those homes performing better than those assumptions, which means actually there's a cost saving for the client. So do you actually need to specify that thickness of insulation? Do you need to go bigger with the heat pump, for example? So there's a lot of value in measuring both new and existing homes. And to be honest, it can go either way.
A few minutes ago, you mentioned EPC. When you look at a property that's already been given an EPC rating, how do you find that, the thermal performance? Does it sort of marry up in order as you might expect, or is that all over the place?
It tends to be all over the place. What we would say is most properties that we test, the design and the measured values almost never tie up, whichever way it goes, because we're almost always getting it wrong, whichever way that may be. In terms of existing properties and EPCs, the process is something called RDSAP, which is Reduced Data Standard Assessment Procedure. So we will pluck thermal values from standardized tables based on the building's construction type and what year it was constructed in, and we will come up with a basic thermal specification for that property. The issue is now that we're looking to upgrade however many million homes across the UK, those thermal specifications are being used to then make decisions on fabric upgrades and what needs to happen. But as we know, that's a stab in the dark, and quite often it's not representative of what is there. So what we find with existing properties in that reduced data approach is that we measure them, and sometimes, the building is actually better than thought. And it means that, ultimately the client can have a cost saving. The retrofit strategy can be reviewed before it's rolled out across 80,000 homes. And there's serious value and savings in taking that a measured approach to retrofit, to be honest.
And that's another point, really, that even if homes are part of one development, presumably your test can uncover different problems in different buildings. It's not just one development has all the same results.
Yeah, exactly. So, you might do a sample on a development. You might get two identical homes that perform very differently. And ultimately, the homeowner is then burdened with that underperformance and probably none the wiser. So this is what we're trying to do is kind of identify those pitfalls in that construction process. A bit like air testing when it was introduced. Everybody at the moment prides themselves on their air tightness results, certainly in the passive house sector. So what we're trying to do is get people priding themselves on the thermal performance, the overall performance of their property, rather than just that one element, which is important, but is far from the whole package.
Air tightness and insulation together, they almost go hand in hand. Are there any other factors that should be considered as we look at this overall picture?
Yeah, so there's the ventilation element ultimately. So because we test the property before it's occupied, we don't measure the ventilation element because quite often it's lots of different things, whether it's natural ventilation, i.e. people opening windows, or mechanical ventilation like MVHR systems. So it's fantastic to get a thermally and airtight property, but actually when you do that, you need to make sure that the ventilation element is correct as well. That can be monitored long term. So we're looking at a monitoring solution that can then look at the property in use to ensure that kind of internal environmental conditions are as they should be. But really, there's three elements to fabric performance. It's ventilation, insulation, and air tightness. And you've got to get all three of those right to achieve a high-performing property.
When we're building passive house, we have an air tightness test. And, well, actually, you probably have more than one air tightness test. But one of those interesting points is that you're trying to get it as good as you can. And so you have that snapshot at a certain point. Is it exactly the same point that you would test the insulation and how that thermal performance is going?
Yeah, so we have engineers that will come and do air tightness and Veritherm in one visit. So we test at the same time normally as the air leakage assessment, which makes it a seamless approach. You get one engineer, he turns up, he does the range of services and then comes back to you with all the numbers and the reports the following morning, so that the project delivery isn't affected by that test being implemented during the project, which is quite useful and beneficial and means that everybody is getting clarity on where things stand with regards to performance before the building's signed off, which is ultimately where the value lies.
So where would you like to take this then? You've got to, or is it just trying to get more people to see the benefit of doing these tests?
I think the end goal is to get this incorporated into legislation and things like Part L of building regulations. We've got the introduction of the future home standards coming in, which gives a requirement for photographic evidence of insulation performance, but that's quite tricky and time consuming. So what we're trying to do is saying, look, implementing measurement techniques is actually probably a better way of doing it. Until that happens, it's all about growing demand and proving the different value to all of the different stakeholders that we work with. So whether you're an architect that wants to kind of understand how properties are performing in use and then implement that into your future projects, right down to product manufacturers who want to understand how their products are performing in situ. We work with a wide range of clients. And between now and later iterations of future home standards, we're looking to just scale the service and evidence what value it brings to all of the different people that are involved in the construction supply chain.
Are there any other aspects that are important that I haven't touched upon or perhaps don't grasp?
Not particularly. I mean, the only thing with thermal performance measurement is it's seasonal. So obviously we've got to achieve some kind of temperature difference between inside and outside. July and August tend to be the most difficult months to test. But other than that, it's quite a robust and dynamic system at this stage that can be, you dump the kit in, you leave it overnight, you come back and it gives you a result. Once people start to get their eyes on the data and the information that comes back, we tend to find that they roll this out on other projects because it's very useful and interesting data to have.
Well, Tom, thank you very much for your time. Really appreciate it. Cheers.
Yeah, thank you, Ben.
Head online to take a look at the show notes that accompany this session, houseplanninghelp.com/308, where you can review the key points again in our summary, or perhaps you've got a comment or a question. You can do that within the show notes if you head down to the bottom, or on social media. We'll give you all the links you need, plus to Veritherm, houseplanninghelp.com/308. Let's finish on a hub update. We're on to episode 3 of the Kimver story. So this is another one of our in-depth video case studies. You may know that I run a production company, so I like to use video wherever I can. So we follow entire projects and try to highlight key aspects, things that we can learn. We're always interested in the decision-making process. And this is also part of Alan Budden from Eco Design Consultants. It's one of his retrofit projects. And more than anyone, I would say that Alan has a lot of experience in retrofit. I think he quite likes it because it's so complicated. He's obviously so intelligent. That's why he likes all these things. So we're following this one at Kimver, retrofitting as well to Passive House standard. It demands a lot of time and attention to detail. We've heard this all before in Passive House, but you're not starting with a clean slate. You've got to deal with what is there. So a lot of stripping back. And unfortunately, in this particular episode, we've uncovered a nasty. The bay in this Victorian terrace, it's got problems with rot and the stonework is cracked, and really the fate of the bay lies in the hands of the structural engineer. So we will await to hear back on that. And in this particular episode, having just taken a look, Alan points out very important. You must have a contingency if you're doing a retrofit, because something like this always crops up. Hopefully it's not something where you need to completely rebuild an element, but it might be. So have that contingency set aside. Also in the hub, yes, you know the score. We're working on some new courses, which I hope to tell you about very soon. We've got live training. We've got the members only forum. You can get input from me on our regular office hour calls. So we try and just help you, give you a little helping hand. houseplanninghelp.com/join. You may be aware that Archetype is one of my favourite architecture firms. I think they go a long way in trying to make their buildings as ecological as possible. So it's quite exciting that 2 more of their architects have built a house. We'll be catching up with Polly Upton and Kirk Rushby next time as they share their self-build story. Tight on cash, so we love that. How are they going to be innovative? That next time. Thanks for listening. The House Planning Help podcast is produced by Regen Media, content that matters.